Today, let's look at init only setters. Now, init only setters gives us a more consistent syntax to define immutable object properties. Also, if y'all are wondering how my code or my entry point, that is program.cs file, is like this is because of top level statement. I will leave a card in the video and a link in the description to check out my videos on top level statements. Now let's continue with init only setters. For that, let me create a new class and I'll call it person.cs, and I will open the person.cs class. Over here, let me create a public class called person, and it's going to have two properties: first name and last name. So prior to init only setters, the way we would do immutable properties was by removing the set keyword. So this allowed the properties to be set only in the constructor of the class. So I can have a constructor which would kind of take two input parameters. That would be first name and last name. And then the properties would actually be assigned to the input parameters of the constructor. Now, if I were to use this in the program here, so I can call person, person, new person, and I would have to pass it the first name, in this case John, and the second name, in this case Doe. And this would basically initialize an object for us, and just to see that it has worked, we can have a method over here called display full name, and the job what it would do basically is just uh write line first name and last name. I would have to, I forgot to put a return type over here, and would have to add a using of type static for system.console. Now that that's done, what we can do is we can call person and say display full name, and we can go ahead and build the application or directly run the application in this case. And it looks like there is an error. The new right line does, oh, right, RIGELINE, right line. Yes. And now, as you can see, we have John Doe over here. Now, we have made the properties of first name and last name immutable. That means once the object is created, we are no longer able to override the properties with some other value. Basically, it's going to throw us a compile time error here. Okay, As you can see in this code, to make these two properties immutable, we had to remove the setters and actually had to have a constructor to assign the values at the time the object was getting created. Now imagine this object gets two more properties like social security number and birth date, and those two new properties also would have to be added in the constructor if they were also to be immutable. So as you can see, as the number of properties grow, the code in the constructor also grows. To avoid this, or better yet, to provide a consistent syntax, C#9 has introduced the init keyword. With this code is currently also valid, where the two properties now have the init keyword and they can be set in the constructor itself. We can check that by running the code, and it should work exactly in the same way it did. But now, since we have added the init keyword, we no longer require the constructor here. We can get rid of the constructor and actually initialize or pass these values at the time of object initialization. You can call it John and last name would be Doe. Now, on doing these changes, basically the program will run in the exact same way. The only advantage that we get is now our class is much more smaller. It kind of gets rid of the code in the constructor that was just there for the sake of producing immutable objects. Now let's see how the init keyword actually plays inheritance type of scenarios. For that, let's create a new class. Let's just call it base and derived. Let's just open this class. Now, well, what we'll do here is let's go ahead and create a class called base, which will act as my base class. And basically, the base class will have a property of boolean type, let's say value. And let's just see the old way of doing this without the init keyword. And let's just say it did not have the set property. And if I had another class called derived, and what the derived class did was actually inherited the base class, and basically what we needed to do is, in order to set the value, we would have to, since the value of the value property cannot be set in the base class, if I would do a constructor, since it's derived and remove the parameter, if I would take and try setting it a value, it would basically throw an error because the in this case the value cannot be set outside of the class or cannot be set inside of the base class or inside of the derived class. It has to be set in the base class. So what we have to do is we would have to have a constructor that would kind of take a boolean parameter, and then this parameter would be assigned to the actual property. And then in my derived class, what would happen is when the value passed, it needed to be passed to the base class constructor so that it could set the property value for the base class. Now, in case of init, and the way this would be used is basically we would go over here in the program class and just have derived, create an object of type derived, and we would have to give it the value so that the values property could be set. Now with the now how does this code change with the init keyword? We can introduce the init keyword on the values property, get rid of the boolean class here basically, because now it's a init style property and actually can be set when the derived class is actually getting created. So we can remove this. We can also get rid of this property, and if we wanted, as if when the derived class was getting created, basically the values property now can be set like this also. But in this case, we won't be doing this. We would be passing it uh, is an object while doing the object initialization, and it would be passed like this. At this point, values is set to true, and it sets the parameter which is there on the base class, the immutable parameter that is there on the base class. So this is how we can leverage the init keyword in an inherited scenario. Program runs correctly, just so that there are no runtime errors with this code. Looks like everything works fine. So now that the program works fine, let's just look into a complex scenario where we have a class with read-only fields and also init properties, and let's see how that can be used and the way the init can be used as a method, how set was. So let's just go ahead and create a class called complex.cs, and we can open the class here, and what we can do is we can have a class, call it basically complex. Now, what does the complex class have is the complex class has a private read-only integer field 1. Then it has a private field 2. In this case, the field 2 is not actually read-only. And now it has a integer property, say prop1, which is again init property. And then we can have another property prop2, which is also is a getter and a setter, and we can replace this set with init. And what we can do is we can basically try and have a function here in which what we can do is basically go ahead and set the fields with respective values, like 2, field 2 would be property 1 would be 44, and the get is kind of throwing an error. So what we can do is we can say return prop2. What we can do is 45. So with this, you can see that the init method, you can also call the read-only fields also. Basically, it acts similar to set it in the constructor of the class. Again, let's just run the program and check whether the code runs fine and it does not throw any runtime exceptions. These are just warnings that the fields are never used. Basically, they are assigned, but the values are never used. Yep, that's it for this video. wherein we cover init only setters.